Hello everyone, welcome to Smart Farm Insight. Across the cold northern waters where rivers meet the sea, one of nature's most extraordinary migrations begins. Salmon are legendary for their ability to travel thousands of miles through open ocean currents and then return, with astonishing accuracy, to the exact river, the exact stream, and often the exact gravel bed where they were born. This incredible internal compass has fascinated biologists for generations. Today, salmon is not only a symbol of nature's resilience, but also the backbone of a massive modern aquaculture industry that supplies millions of tons of fish every year. Behind every salmon fillet, every sashimi slice, and every vibrant orange roe lies a precise, technology-driven farming system that begins with the smallest of life forms, salmon eggs. In this video, we take a deep dive into the entire salmon production chain, from hatchery to open sea cages, from AI-assisted feeding systems to cutting-edge processing lines, revealing the hidden world behind one of the planet's most valuable cold water fish. Salmon farming begins in specialized hatcheries, where adult broodstock are carefully selected based on size, health, and genetic quality. Under controlled conditions, mature males and females are brought into spawning rooms. Workers gently extract eggs from the females and fertilize them with milt from the males. This controlled fertilization ensures optimal survival rates while minimizing disease risks that wild populations often face. The fertilized eggs are then placed into incubation trays, surrounded by clean, flowing fresh water kept at precise temperatures. Over the next 4 to 12 weeks, the embryos gradually develop. Their bodies form beneath the translucent egg membrane, and tiny heartbeats begin to flutter before hatching. Once the eggs hatch, the newborn larval salmon, called alevins, emerge with a large yolk sac still attached to their underside. During this period, they remain near the gravel-like bottom of their tanks, absorbing nutrients and gaining the strength they need for their next stage of development. When the yolk sac is fully absorbed, the young fish enter the fry stage. Now free swimming and hungry, they begin feeding on specially formulated pellets designed to support skeletal growth and organ formation. Their bodies develop distinctive markings known as par lines, vertical stripes that help them camouflage in freshwater environments. As the fry grow, they are transferred into larger indoor tanks equipped with precise water quality control systems. Automated feeders deliver micro-portioned meals several times a day, ensuring uniform growth across thousands of individuals. Constant monitoring keeps oxygen levels, water flow, and temperature within optimal ranges, providing conditions far more stable than those found in the wild. After several months, the salmon reach the smolt stage, where their bodies undergo physiological changes that allow them to tolerate salt water. This transition marks one of the most important points in their life cycle. To mimic natural migration, farmers gradually modify water salinity inside the tanks, preparing the smolt for their future in marine cages. Once fully adapted, the fish are transported to open sea farms using oxygenated transport tanks that keep them calm and healthy throughout the journey. These massive offshore cages are anchored in cold, deep waters where currents constantly refresh the environment. Each cage can hold tens of thousands of salmon, monitored day and night through underwater cameras, sensors, and automated data collection devices. High-resolution cameras track swimming patterns, density distribution, and schooling behavior. If salmon begin to slow down, rise too close to the surface, or cluster unusually tightly, AI analytics flag the condition. When oxygen begins to drop, the system automatically triggers aeration devices or adjusts feeding patterns. Overfeeding is a major problem in traditional farming, often leading to waste, pollution, and disease outbreaks. But with AI-controlled feeders that release pellets only when fish are actively feeding, waste is reduced dramatically. Once salmon reach harvest size, typically around 4 to 5 kilograms after 18 to 24 months in sea cages, specialized vessels equipped with pumping systems and oxygenated tanks arrive at the farm. Salmon are gently guided through pipelines into the transport tanks, minimizing stress and physical damage. From here, they are taken directly to modern processing facilities where strict cold chain conditions are maintained from the moment the fish arrive. Inside the factory, the salmon are preserved at near freezing temperatures to maintain freshness. The processing line is fully enclosed and temperature controlled. As each fish reaches the first workstation, workers expertly handle the head removal stage. With swift and practiced movements, they detach the head while automated machines simultaneously trim the tail. The combination of human finesse and industrial precision ensures both speed and accuracy. After decapitation, the salmon proceed to the filleting line. Advanced side-cutting machines slice the salmon into 2 symmetrical fillets, neatly separating the spine and major bones. These machines are calibrated to maximize meat retention while maintaining clean, even cuts across all sizes of fish. But mechanical precision is only the first part. The next steps require meticulous attention from trained workers. Any remaining pin bones, small hair-thin bones embedded deep in the fillet, are detected using specialized sensors and then removed with gentle tools or automated bone extraction machines. This step ensures the fillets remain boneless while keeping their natural texture and fatty marbling intact. Once the bones are removed, the fillets move to the trimming conveyor. Skilled workers trim away excess edges, uneven sections, and thin strips that could affect the final product's aesthetic quality. Premium-grade fillets destined for sashimi markets undergo even stricter inspection, ensuring flawless color, firmness, and fat distribution. Next, the salmon enters the final inspection zone. Workers check each fillet for defects before sending it into vacuum sealing machines. Vacuum packaging removes air, drastically slowing oxidation and moisture loss. The sealed fillets are then immediately transferred into cold storage, where temperatures remain between 1 degree Celsius and 2 degrees, ensuring maximum freshness during transport. Salmon has earned its status as one of the world's most nutritious fish. Its health benefits extend across heart protection, cognitive support, immune enhancement, and skin health, making it a favorite among both chefs and nutritionists. From the moment an egg is fertilized in a quiet freshwater hatchery to the moment a pristine fillet is vacuum sealed for global export, the salmon industry blends biology, technology, engineering, and human skill into one seamless system. It is a story of careful design, continuous innovation, and the timeless rhythm of a species that has been migrating for millions of years. Every salmon fillet represents a chain of effort. Farmers monitoring tanks at dawn, engineers tuning IoT systems, workers filleting with precision, and processors maintaining strict cold chain conditions. This is the unseen journey behind one of the world's most beloved fish. A journey shaped by science, tradition, and the relentless instinct of a creature that always finds its way home